Hi, Roselle. All right. I have been trying to find something similar to this, and I haven't so far, but I'm sure I will once I figure out what on earth we're dealing with. My brilliant son, who just finished grade 10 math, helped me a lot to kind of picture what was going on here. Because remember, I was saying that I thought we had like two different Pythagorean triangles because something was changing in between and I was missing something. And then I had him read the problem and sort of describe it to me as he saw it. And I realized he was right. He said that it was not a Pythagorean triangle because the drone's not moving in a straight line, right? Um, if if this is our intersection and this distance is 1 kilometer away when the train passes, then the drone's leaving from here, and let's say he's sort of heading towards here now when he sees, the train. That's just sort of over what do you call it, exaggerating the distance up on the x-axis there. But he would be moving in a straight line like that if the train stayed put, right? But the train's moving, so a second later it might be here, and now he has to go like that. And then if it was here, you'd have to go like that. So it's a whole series of different triangles. So it's not a Pythagorean triangle at all. What it is he's moving in a curve, right? He has to keep adjusting his direction, and so he's moving in a curve, and that shouldn't be quite as wavy. It should be a smooth curve like that. So I think that what Stefan is trying to tell you when he says that dy dx equals 0 at x equals 1 is that we're looking at a parabola where at this point x equals 1, we don't know what y is, but we do know that dy dx, or the slope at that point, is 0. In other words, that's a turning point, so it's got to be a max, right? So then it's going to start to come back down. So one of two things is happening. Either this is the point where the curve intersects with the track, with the train, or the intersection has already taken place before that, and he's just giving you that information so you have the max and so you can find the equation of our parabola. So we're going to assume that this guy is an upside down parabola. So it would be in the form like minus ax squared. But it's also like when we draw it on our grid here, let's do this at -1 because this is how he told us. He said the track was like through the origin. If we draw it like that kind of thing, then it's also, this point here is the vertex. The vertex PQ is moved over 1 and up. We don't know, right? And so instead of y equals negative ax squared, it would look like this. For the equation. So I don't know. Let me see what else he told us. Did he tell us a point? So with y equals 0, I'm not sure if he's trying to tell you that that point is on the axis or not. And I don't think we can do it unless we know. Because we have too many unknowns here. Like the only thing we know is dy dx. But only at this point for the parabola, right? Like we know the speed of the drone, and that's the slope of the parabola, but it's only at one specific point. So it's 200. So for it to keep a constant speed, which I think it has to do, is really weird, because then that's the slope of a parabola, which should be changing because, oh, I know, it's dy dt. Yeah, dy dt is 200, not dy dx. That makes more sense. Okay, so I don't know. I'm assuming he wants us to come up with this equation and assume that Q is 0 because they're going to intersect at that turning point. If it's not, then we've got a heck of a job just trying to figure out the equation, and I don't think that's what he wanted. So I'm assuming that this is the equation of our parabola of this guy. And so what this question actually becomes is trying to find the rate of change of the distance from a point to a curve. So let's say that we were at this point on the curve, and we want to know the rate of change of the distance. We would draw our Pythagorean triangle here. There's the hypotenuse, and then we would make a triangle out of it. The problem there is that labeling these sides, this is easy because this is just x here. This one has to come from the equation. So there's several examples of doing this where you're given the equation of a curve. Not too many where you're doing it from -1 instead of from the origin. So I'm just wondering if maybe we should now move the curve up to the origin, like move this point here up to the origin, and to make it a little bit easier. So I just kind of wanted to think out loud and explain where I am so far with it, and I'm going to think this through a bit more and decide how we're going to proceed from here. But that's what we were missing this afternoon, was that it wasn't a straight line at all, it was a curve. So when you're searching for things online, what you want to search is finding the rate of change of distance from a point to a curve. And that's where we'll find an example similar to this. So I'm sure we'll get it figured out by Wednesday, but I'll keep working on it. We're going to be out of town tomorrow, but I can definitely do something more on it on Saturday for you, okay?